All right. Can anybody else become the organizer? Who want to become the organizer? Who can start the recording? All right. I'm making Yashwant. All right, Yashwant. Make organizer and mute all. Okay. Have you started the recording, Yashwant? Great, great. Now let's. All right. So what we have done so far is we have downloaded the project from the session number 5, and we are importing that project into Eclipse. All right. Now we have created a fresh new workspace inside Eclipse so that we have no confusion. And then we are saying import. All right. Import, we say existing projects into workspace. Click on the folder. Uh, Click on browse button. All right. So the one which we have downloaded just now is located in downloads folder, and we can simply go into TRG2. TRG2 is the one which contains the project. All right. Now you can see it has found the project inside TRG2. All right. Now there will be a minor problem like reference libraries problem for you. Okay. So what you do is you go over here, go into properties, go into Java build path, remove all these libraries. Okay. Except for JRE and TRG2 SRC, you remove all of these libraries. I think those will be only visible over here. Yes, under libraries tab, after going into right click properties and Java build path, under libraries tab, you will see all these libraries. Just remove them, okay, and then add them again. Okay, for me it was not giving error because it has found somewhere else. Now for you it will give error. You go back to the folder which contained your TRG2 folder. This is the one which contained Java, but there is another folder called libs which contains all the libraries. All right, that's it. Now, now this will be able to do everything. Now let's just clean the project once, and then we export the project. Okay, and here just type jar, so it will search for the jar node. Okay, and then what you can do is you can simply export it to some place. I want to export it to my downloads folder. Okay, we can go to my downloads folder, and not this. Okay, I'll just move to my downloads folder. Okay, and where is, yeah, here, users, under downloads, I'm saving it, let's say, as mr10 gen.jar. Okay, so that's my output folder. It says jar creation failed, resource out of sync. That should not be a problem. Okay, now this is successful after trying again. Yeah, um, those were the extra files which this guy uh, Mac keeps on adding. All right. So here we have created the jar file. You can see here it's created. Now what we have to do is we have to upload it to the server. Okay, upload. Let's do it in two steps. First, we will upload it into HDFS. Then we will use Hadoop to copy it to the local folder. All right. So we'll copy it to HDFS using Hue. All right. So where is my download folder? Here. And okay, let's see. It says connection aborted, no route to the host. This problem, I don't know why it's happening, but I'm able to solve it by compressing the file and then saying upload zip file. Okay, uploading zip file. All right, I'll take a look at why it's giving that error. Now it must have uploaded. Let's sort it by date. Let's sort it by date. Now you can see there is a folder here containing this. All right, let's copy. Now now we have uploaded this newly created jar. And how did we create jar? Using Eclipse, we imported the project. We downloaded the project from LMS. We unzipped it, imported to the Eclipse, fixed the jar problems, the library problems by removing and adding the external jars again. And then we exported the projects into jar, and then we uploaded the jar into HDFS. Now what we will do is we'll log it into console, because Hadoop jar command expects the Java bundle, which is jar file, expects jar file to be in the local folder, okay, not in the HDFS. Therefore we'll have to copy it from HDFS to local. And why did we copy into HDFS? Because it's easier to do it without installing any software using Hue. Okay, the only extra step which we had to do is we had to compress this jar file into zip and then upload using Hue, this one, because I do not know, for some reason Hue has been giving the errors unnecessarily. We'll have to take a look at it. All right, that we'll take a look at it today. Okay, now we are trying to log in into our CloudX Lab console. All right, we are logging in. Then we copy the password, paste it. All right, this is the console. This is the Unix console. Generally, you use SSH to log in into the servers, but we are using VATI so that you don't have to install too many tools on your desktop. Okay. Otherwise, everything else remains same. It's only the VATI, which is browser-based console, which is different. Otherwise, rest of the things are exactly the way it happens in organizations. All right. Now, the first thing we'll do is we'll bring the file to the local directory by using Hadoop fs copy to local. And what is it that we are trying to copy? We are trying to copy this particular folder. So the easiest way to do it, to get the path, is from the Hue, and we say star.jar and dot. So it will copy all the jars inside mr10 jar.jar, because when we uploaded, it created a folder with this name. Okay, so all right, so we have this one here. Okay, let's start. So we say Hadoop fs minus, not Hadoop fs, we say Hadoop jar and just write the name. It says give the main class name. How do we know the main class name? It would be, so Hadoop jar expects two things from you right now. One, the name of the jar file. Second, the main class, the entry point name. Okay, which is this one, step driver. Step driver is our entry point name. So you can see that package my here, and inside my there is step driver. Okay, so we have my dot step driver. All right, you have input directory, you have output directory. All right, now you can see that this particular error is coming from our code. That means Hadoop has been able to at least execute our binary. All right, there is nothing wrong with our binary. Now we can give the path to step driver. This path has to be in the HDFS. So we say data, MR, word count, and slash input. And the output, let's say MR10. Okay. So that's our output directory. It's trying to do something. And just give me a second. Alright, looks like one of the node is giving problems, but I think that won't be stopping us from. Alright, so we are running the job here. You can see the progress of this job using this URL which Hadoop has provided us. You can see that the job has been accepted, waiting for application master container to be allocated and registered with RM. Alright, so it's waiting for some process to finish. Alright, let's see, let's have a look at the console again. What's going on? Alright, in the meantime, we can check Ambari. Alright, now the process has started. You can see here. Okay, now it's running the two splits here. And why it's running two mappers? Okay, alright, alright. So it's basically a second attempt here. It's trying to do multiple attempts. Alright, yeah. It's trying to do some execution. Alright, now the application status is running. All right. So I hope it'll finish very soon. All right. So I think that is good enough, Medili. Any other questions at this point? Okay, so you can see that the process is in midway. Yes, Yashwant is saying, can you cover step testing and MR unit? All right. So, okay, let me just see. Can you cover step testing and MR unit? So, MR unit is quite straightforward, and I'll just explain to you. I'll show you the code. I think that will be better. All right, let it finish. All right. So here, all right. So I'll just show you my step test. Okay. So step test is basically uh, like every other JUnit program. The name of the class has to be generally suffixed with the test. Then you have to have one program called setup, and then other functions with the name prefixed with test. And optionally, you can also put at test. In the new JUnit, you can put the annotation, which will basically help the framework figure out which functions are test cases. So each function is a test case, and each function is supposed to test some part of it. All right. And as usual with the testing, you try to test as smaller part or as smallest units as possible. So in in MapReduce testing as well, you test the mapper, you test the reducer, and then you test both of them together. All right. So for testing mapper independently, you should be able to execute mapper. And how do you execute mapper independently is by creating an instance of step mapper here and then setting that to the map driver. All right. So in the beginning itself, what you do is you first create and define an object called map driver and reduce driver and map reduce driver, and then inside every setup, so there is a setup because setup is run before the test case is run. All right. So inside that you initialize map driver, reduce driver, and map reduce driver. Okay. What does map driver do? It is a dummy executor of the mapper. Okay. It is the dummy executor of reducer, the reduce driver, and map reduce driver is the dummy executor of the mapper and the reducer. So you provide an instance of your code. This is the same code that we just ran. Okay, this is the same code that we just ran. So we create an instance of our mapper, an instance of our reducer code, and hand it over to map driver and reduce driver and map reduce driver. You can see that for map driver we are handing over here. You can see we are saying set mapper and our mapper. And what is mapper? It's an instance of our mapper code. Here we are setting the reducer instance by this object. Alright. Similarly, for map reduce driver we are setting both mapper as well as reducer. Alright, so that's pretty much. Now all we have to do is, once we have created these three drivers, map driver, reduce driver and map reduce driver, these are basically testers. They help us test individual. Now we can make calls to them. Let's write a function called public void test mapper. Inside it, map driver, we are setting input key, input value. Okay, this is the input data we are giving to the mapper, and then we execute the map driver. It executes and gives the result to us here, and then we can traverse, we can iterate, or we can observe what is the result of the mapper. So we are checking. So this x will be okay, this x will be the Alright, this X will contain the key value pairs, whatever is being given by your mapper code, and then you can compare whether this is correct or wrong. Alright, now you can see that we have provided an input text as a single line, correct? Now, this our mapper code will break it down into multiple key values, okay? And that's what we are checking. We are checking whether it has broken down by saying x dot get 0 means get me the first key, and get second is this, correct? So get first is this. Now what will be the get second? Get second, okay, will be a value called 1. Okay, let's see if this is correct, and we run it. So it says expected 1, but okay, expected is string 1 but was this. So we have to remove toString, and now let's try to run it. Correct? What does it say? It expected the long writable, but it was the okay. Let's create new long writable. Okay, new long writable, and we put 1 here. Let's see if it runs fine. Correct? So that means everything is working fine. Make sense to you now? So similarly, we can test other parts as well. So we are saying for 0th record, which is 0th key value, give me the first, as in give me the key, and compare it with whether it's this. Give me the second, compare it with 1, and so on. Similarly, we can assert. The assert equals are the methods which signify to the JUnit that hey, we this is if this fails, that means our test case is going to fail. All right. Now, Midli's question is, did it make sense, Yashwant? Was he able to convey? Great, great. All right. Now, there are a few more questions, very good questions. One question is from Midli saying, you are executing only mapper class, right? Can't we execute mapper reducer driver at a time? Of course we can. And that's why that is another test case. You can see the last one. You can see the last one here. This one executes the map reduce driver. We are adding the content, the input data here, input data here. You can see that. And then we are running it. All right. And then we are checking whether it's correct or wrong. Okay. So we are saying the output should be 11 in size, and there should be 11 records, and then we are iterating over the pairs and printing the data. All right. Again, we can start running the run. Here you can right click on stub test, and automatically Eclipse will give you this option of running it as a unit test. See that? Here we have intentionally put an error saying please implement the test. Now Mahesh's question is, why are we calling set mapper and set reducer twice? Okay, actually we are calling set mapper thrice and set reducer, sorry, yeah, we are calling it twice. Why? Because we have three things. One is mapper driver, other is reduce driver, and other is map reduce driver. These three executors are different programs provided by MR unit. Okay, MR unit is map reduce unit testing framework. Okay, so these are the main things which are provided by MR unit. Rest is just JUnit. So these are what we call, these are pseudo executors. They imitate the behavior of Hadoop. Map driver imitate the behavior of Hadoop's map process, while reduce driver is something which mutates reducer's behavior, and MapReduce driver of MR unit behaves as if it's a proper Hadoop MapReduce engine. All right, that's why for each of them separately we have to specify the entry points. Now, Yashwant's question is, if you want only the mapper, is there something you can comment out? All right, we did not comment out. Actually, the beauty of this MR unit or JUnit framework is that it lists all your functions independently. So ideally, what you should be doing is you create separate function for testing separate functionality. Generally, for every program, you should have multiple mapper testing and multiple reducer testing, and we should have multiple functions for testing the main MapReduce process. Okay, so all we have to do is list down individually, and if you want to test just this part, you can right click on this and just click on run. Okay, so it will only run our MapReduce. Mahesh, did I make sense to you? And Yashwant? Good. So everybody comfortable with this mode of testing? All right. So initially, as a matter of principles or as a matter of practice, you should always create in the beginning itself various kinds of test cases. Okay, because that will make your overall productivity and overall code really robust. How? So you start with creating the test case. Test case is something which dictates the specification. So you write the test case in the beginning itself saying, if I give this input, I should expect this output, and run it. Initially, everything will fail, and let it fail. So you write your test cases in the beginning before starting to code. That basically becomes your guiding force. Okay, so once you have the test case in place, it'll give you a very good thought clarity on what exactly has to be done. Although lots of people say that, okay, this is not my job, let the testing guys do it. No, it's everybody's job. It gives a, it gives a great thought clarity on what exactly are we trying to achieve. And mostly in the software development, it is the problem with the thought clarity on what exactly are we trying to achieve. All right. Therefore, writing test cases is actually better for overall performance and overall productivity. All right. Now, Yashwant is saying that is there a standard way of debugging? Okay. Can we drive the testing by giving the input from a file? Of course you can. Of course you can. So you can basically load the data at this point here. Here we are hard coding the strings. Did you see that? We are hard coding these strings. You can simply load this text from a file and hand it over to the map driver. All right. MR unit does, I think it, JUnit provides you way to load text, or you can write a simple file reading program from which you can read this text and feed it to the map driver. All right. Good. So that was our recap of how to do things in Java. All right. All right. So let's continue our discussion from where we left. All right. So the things which we discussed yesterday was that since HDFS blocks are based on number of bytes, therefore you have to convert that into some logical form. And for converting the raw data into logical form, you the whole block may not suffice. Therefore, you might have to fetch data from other nodes. Okay. So all of this fetching of the boundary or fetching of the remaining portion of a record from another node is done by something called input format. Okay. So the conversion of a raw block from HDFS into input split or input, or you can say that converting a block into set of records is a process that is done by input format. By default, we have many input formats available to us. And even if you do not specify which input format you want, Hadoop automatically gives you the text input format. Okay, what does text input format do? It converts the raw file into records. And records here are the lines which are separated by /n. So it breaks down the file by /n and then creates record for each of the line. Okay, and bunch of the records become the input split. Okay, so this is our default input split. Let's say you realize that for your kind of problem you do not have a way, you do not have a existing input split. But honestly, before you jump into creating your own input split or own input format, okay, so for most of the problems, you will find the input formats available online. For example, loading XML file, loading JSON file, loading zip file, loading MP3 files, converting or converting a geospatial file into records, converting a bunch of files into a zip and then loading it such that each record is a file. All of this is available by default with 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 our Hadoop. If you are not sure that it's available, do a Google search. Most likely you will get a input format to solve your problem. Okay, if you are not getting an input format to solve your problem, and you have this special kind of format, then I would strongly recommend to convert your format into sequence file. If your format is kind of a binary like MP3, MP4 or AVI, then plan for converting that format into sequence file format. Okay, and that would solve a lot of problems. So my general recommendation is, if you have got your special input format, try to convert that into an existing one. If not, then you go ahead with creating your own input format. Okay, so for example, all right. So Abhay's question is, does Hadoop allow stepping through the code? Does it allow debugging? So right now, I'm not sure if it allows. Okay, but every Java process can be remotely contacted and remotely connected, and you can traverse through. But the problem with Hadoop is that every code will be running multiple times, because for every input is split, your Java code will be your Java code will be instantiated. Your class will be instantiated and executed. So there'll be many copies of your code running in the network, and predicting that which node is running your code will still again take time. Therefore, it is generally recommended not to do the stepwise debug. If you really want to do stepwise debug, do the stepwise debugging of your unit test case. Okay, you should do the unit test case debugging stepwise, and rest of the things you can leave it to Hadoop. And to debug Hadoop situation, you generally rely on logs. Okay, because it's not practically possible to remotely connect to all the map code, all the Hadoop instances. All right, but it's a good thought, and think we I should do a little bit more research. Let me just make a note of it. All right. Yes. So you can see that. Yes, we can do. All right. You can try to do the way we said run. You could just click on debug, and it will take you stepwise through your whole code. All right, Abhay. Good questions. All right. We have now Yashwant's. We have Yashwant's question, and there is Murli. Do you have a question? All right, Abhay. Did I make sense to you? All right. Now, yeah, Yashwant says that. So input format drives the input split. Yes. Basically, block gets converted into block gets converted by input format into input records, basically records and input split. Okay. All right. Now his question is it the block size or the input split that drives input format? The answer is it's a function of both. If there are few, if the input format, if the block size is smaller, if the block size is smaller, then the number of records will be fewer, and therefore input split will contain fewer number of records. Correct? The input split tries to keep its size, or the way we design input format is we try to keep input split size as closer to as the block so that the boundaries are transferred really less. Otherwise it'll take a very long time to transfer data from one node to another. All right, now coming back to it. Yes, Murli, you have a question, you have raised your hand. All right, there's a question from Bespa. question is Question is, in a typical example of a file block containing XMLs, what would normally be my records and input splits? In a typical example of file slash block XML, what would normally be my records and input split? Let's take a case of one XML. I'm just giving an example. Let's say there is an XML which contains equipments. Okay, and each equipment ID equals 1. Okay, and let's say date of manufacturing is, okay, we call it date. Okay, and we call it name equals to manufacturing, and the value is some, let's say 12012011. Okay, and so on. And for each equipment, this is the case. There are many such equipments, and let's say this data is going up to, say, 1 million records. Okay, 1 million attributes we call it. All right, now there are many such equipments. Let's say ID equals to 2, date of manufacturing is 10, and so on. There are lots and lots of equipments available here. Let's say there are 10 million such equipments. Okay, does it make sense to you? Yeah, I'm trying to write a sample XML for you. All right, let's take this case, and what you want to do is, let's say as part of your MapReduce process, what you want to do is you want to process each equipment in your map phase. Okay, let's say you are trying to find out the equipments manufactured in the same date. Okay, so what will you do is you will iterate over each equipment, and the key you will form out of it is based on the manufacturing date or manufacturing month. You will parse each of this. Now the problem is that how would you convert this XML into how would you convert this XML into records, where each record represents equipment, so that each of the record is fed to your map function. The map function of yours should get equipment from here to here as a single record, and then that you process and only spit out the key of some form. Okay, or here, let's just reduce it. It's like too many. Let's say 1,000 record attributes. It sounds awkward. Yeah. So each map attribute is each map function is getting this. Now who will give you this? Who will convert this XML into in such a way that every record your map function receives is an equipment? Is the problem statement clear to everyone? Bishwa? All right, and trust me, it's actually a real problem which I did for one of the telecom. So, all right, so to solve such kind of problems, it's actually comparatively easy. There was this XML input format. Okay, there is XML input format, and not this one. It's a part of Mahat. It's part of Mahat. There was this input format I'm trying to look for. Yeah, Mahat's XML input format. That's correct. So, so you can simply say XML input format dot class. Okay, and this class is available to you as part of Mahat. So here you can just simply download this. Okay, you can download this or maybe compile this or maybe just add it as a project in Eclipse and then export it as a jar. All right, so you can download this particular file and use it as the XML input format. All right, so all you had to do was use it as XML input format. Then while dealing with it here, let's say your program, where was that? The first one was the answer. Yeah. So I'll show you this part. So here you can see in your map function, you are not this. This is not right. Okay, this is not what we're trying to do. One is that you manually read XML inside your code, which is wrong because what would happen at the end of day is your whole file will be read by a single map node, which is not suggested. Okay. Now here is one thing, not this. Where is this? Yeah. So you can simply say set input format equals to this, and you can specify the XML input name and uh, start and end because it has to identify when does an XML, how does a node start and how does a node end. So you can tell that this is my node which I'm looking for. From here to here is something which I'm looking for. Okay, by setting these conf.set XML input start and XML input end. Okay, so based on that, those tags what you provide there, it will split the file such that each record is created based on this XML node. Make sense to you? All right. All right, can you please post a real full project that splits the block into record and input display? Yes, that's already there. Okay, so this project which we are talking about right now, all right, the one which we have here in the session number 5 or 6. So this one contains a custom input split. All right, it contains a custom input split. All right, so go through this custom input split. You'll get a lot of answers, as well as go through this XML input format that will give you a lot of thought clarity if you are looking for creating your own custom input. All right, although you won't need it generally. All right. All right. Now going back to the discussion. All right, Mahesh, did I answer your questions? All right. All right. So even though you will get the XML input format, it's good to know what is inside input format, so that in case required you can create your own input format. All right. So basically, input format is an abstract class which you can extend and implement the functions like create record reader. And create record reader is the most important function which gives out the record reader. And the system can start reading the records and start creating the split. Okay. Now there's another abstract class which is there in the base classes of Hadoop, which you will have to extend is input split. It's an abstract class. Every input split has got a length, as in how much size, what is the size of the input split. Because it won't be fixed, it will be varying, because record definition is not something which is, record definition is not something which has got the fixed size. So input split will have a length, and the locations in terms of HDFS block name. Okay, from where this input split starts, the HDFS block. Okay, and the length. So these are the two characteristics which are there in the base class of input split. And so the first job of input format is to translate to translate a given input file into splits. The your code which is going to be extending input format is going to override get splits, and is going to override create record reader by providing them the meaningful function names, meaningful function details. So get split will go through the files and create input split at various locations. For example, XML input format will go through the input file and will keep on predicting whether the split has started or ended and not. Okay, and then once you have the list of input split, then the records will be created out of each input split. Okay, the records will be created out of each input split, and the logic behind creating a split is, so first of all, when the process starts, the get split method will be called on every node parallelly given a data block. Now get split will be executed parallelly on every node and will keep on giving the splits to Hadoop, saying that okay, we have got these many splits. And afterwards For each input is split, we'll be converting that into records. And once Hadoop gets the records from input format, then it starts executing maps and reduces accordingly. All right. All right. So that was a very quick overview of the input format. You should take a look at the example given in our s- sample code, whereby we have tried to create an input split, which limits number of records in an input split. So Yashwant's question is, suppose there are multiple attributes, so how will the output record look? Okay, so do you mean to say that in this case, let us say there are more attributes here. Okay, let's say, okay, let's say we have manufacturer, okay, okay, manufacturer, and we call it organization, and we have, let's say APP, right? So it'll be like this, and the one which you will get in the individual record will be this section. Okay, you will get it as an XML node. Then you can traverse that XML node and will get the details of each individual attribute. All right. Yes, we get the entire node as part of, and this entire node selection will be based on xml.start and xml.end descriptions. Yes, inside the mapper, we will have to traverse the node. That's correct, Yashwant. All right. Let's say at later point of time, you realize that you wanted date. Okay, you wanted date as the input to your mapper, only the date. Okay, in those cases, you could say xml.start date and xml.end slash this. Okay, but it will cause problem. It has to be very clearly identifiable. All right. So have a look at this API of XML input, XML input format, and it'll give you a good idea. Okay, so it is XML record reader, and it returns the key and the value. All right. Now it actually gives you the text. It doesn't give you the node. It gives you the text. All right, it gives you the text. You'll have to parse it inside map. You'll have to use XML loader to load this text in this node text. You will get actually the text. Okay, you'll get the text here. You will have to load it and then convert that into the XML node. Okay. All right. Next question from Biswa is the input split division per block? Is the input split division per block is 1 to 1? We try as much as possible. Okay. So it is your definition of input split. Let's say, and why would you like to define what kind of input split you want? Because your mapper instance get created once for each input split. Okay. So if your logic demands that every time you create a class it should be for the fresh input split, in those cases, if your logic demands that your instance should be created per input split, then you cannot retain the one-to-one mapping anyway. Also, also uh, since the boundaries, let's imagine that there is a particular line which is of 100 MB, or there is a particular line which is, say, for a particular file which has only 100 MB lines. Okay, each line is 100 MB. Now you can imagine that the input split will contain only one line. All right. Therefore, it's very difficult to have one input split per block. Sometimes an input split could be over multiple block. Let's say you, even though your line is say 100 MB, each line is containing each line containing 100 MB data. But as part of your input split definition, you have said in the input format that, hey, I want 20 records, I want 20 records per input split. Now, when you say I want 20 records per input split, that means that it would have 20 MB data, 2 GB data per input split. Okay. Therefore, it cannot retain the one-to-one mapping with the blocks. But the best case scenario for data transfer is the one where one block corresponds to one input split. And that should be that we should try as much as possible. Okay. Now, Yashwant's question is with respect to the XML, that can't we just read the text itself? Yes, you can read. But here, the XML text I'm talking about was around, the single file was around 20 gigabytes in size. And that's the exact reason why they came to us, why they came to Hadoop saying, hey, our files are really, really huge and we are not able to process them using usual tools. Can you help us? Right? So the XML file was really big, and these such XML file were there in thousands. Okay, this is telecom company. Now the only thing they had was they need to use Hadoop such that each record that they want to process is is properly created out of each XML node. All right, even though you can always read an XML file and process the data directly. Similarly, inside the map function itself, you can make a call to HDFS and say load the whole XML file. You can do that, but what good is that? Though it will try to load the whole file into the single node, and it will overflow the memory. Does that make sense, Yashwant? All right. So question from Biswa is, in case input splits are spanning over multiple blocks, okay, there will be one instance of the mapper, although the blocks are available on different nodes. How Hadoop is going to process this? The logic is straight for Hadoop. It will transfer all of the nodes, all of the other blocks, all of the blocks, all of the blocks to one node. All right? Is the question clear? It's a brilliant question, and all of you should keep an eye on these questions, because these are the questions which are some people ask in due course of interviews. Okay, so these are very good questions. All right, good, brilliant. Now let's continue. All right. All right, so now we discussed about the conversion of the raw data into into the into the records. This is a very important process, because if you are not able to divide if you are not able to divide or convert your raw data into input format, into an input split, such that the transfer is minimal, you are doomed. Okay, if you're not if your program demands that the whole file should be processed by a single map function, then there is no point in using Hadoop, okay, to process such kind of data, because at the end of day it's running a single process on single node by transferring all the data to that machine. Therefore, you have to have a good clever selection of the input format, so that your workload is divided and there's a minimal amount of work each individual map function does. Okay, everybody can load the whole text file on a single node and process the data. If your data file is small, then you don't need Hadoop. Okay, if your data file is smaller as the whole XML file could be loaded into one node, then you don't need this whole Hadoop. But if your data is really huge, and you will have to think about how would you divide the work, how would you create your processing such that only small sections of the file come to each map function. And this is facilitated by various kinds of input formats available to you. Okay, this first question is, I'm not clear on input split and the record division, which one is created first. Okay, so yeah, I'll tell you this part. So both of it, I mean, this whole process is quite interesting. So first the input split boundaries are created, and then the records are created out of the input split boundaries. I'll show you this. I think this should give you a better idea. Imagine that imagine that there are data blocks. There are these three data blocks. Okay? Now the input format starts in the beginning to convert these data blocks parallelly. Okay? Alright? And imagine that you are basically doing the text input format. There is new line here, there is new line here, and there is new line here. Okay, so first of all, every node will basically start the process. Okay, start the process, and the one which is on the beginning, beginning of the first block, it will say that okay, I have encountered a block. Okay, it will say happily that I've encountered the block. So it will say the sorry, it has encountered the first input split. First input split is on the 0th point. Okay, 0th mark, which is here, right? But second input split will, it will keep on looking for slash n, will keep on looking for slash n, and will mark this point as beginning beginning of beginning of the second input split, second input split, right? And and effectively, when your second input split is here, up to here, from here, from here to here is your first input split, isn't it? Up to here, correct? Now, similarly, on this node as well, it will start moving unless it hits a slash n. And now from here to here, it will mark it as second input split. And the process will happen on every node parallelly. Now, as they go on, so the first thing which is happening parallel on every node is identification of starting of a record or starting of an input split. Starting of a record or starting of an input split is the same thing, correct? Now, after it is done, then it will start parsing the actual data. This section will not be passed by this guy. It will be passed with this guy. Okay? So input format is, this is an input format. So this is an input format, or you can say input formatter if you want a noun. Make sense to you? So it's happening on parallelly on every node, and the first thing that happens is identification of the beginning of the input split. And then once every input format on every node has identified the beginning of their input split, then they will start parsing the data and create records afterwards. Did make sense, Biswa? So then it will say, okay, there is another new line, it has come in. This is one record, this is one record, and this is another record. Similarly, here also this is one record, this is another record, and this is another record. So out of the raw data, it will start to create those yellow blocks. This one, I'm not sure. So we are talking about this blocks, right? This block. Sorry, this block, the one which is currently selected. Those are the data blocks of HDFS. Yes, so the remaining portion of the first is split, which is, this is the first node, this is second node. So this portion will be shifted, to this node. Okay, will be appended to the first node, and this input format will process this section of the data which is coming from the second node. All right. Yes. Biswa's question is, this may cause a memory contention. It does. Therefore, it does not transfer immediately. It transfers it when input format reaches here. When the input format reaches processing here, then this data get transferred, or basically from here itself input format contacts this data block and will start reading the data block directly, preparing the records and handing it over to Hadoop. Okay, it tries to keep this in memory as few as possible. Okay, when it hits here it will try to read from here and start creating the record till here. Okay, it won't try to keep it in the memory. It'll just mark here that hey, we have hit the boundary here, and that is what is called the input split definition. So this section might be traversed twice. Once this input format traversed it, okay, then second this input format will again read it in order to combine it with the rest of its records. Yes. All right, Biswa, that's correct. Good, very good set of questions, and let these questions keep coming. Yes, in other words, we can call them individual logic blocks. Input split is a logical block over the raw physical blocks in HDFS. Very good point. All right. So should I move on, or you have any more questions? Now, Yashwant's question is, if we specify input format as paragraph and say a paragraph is spread over two data nodes, the process will fetch both the parts and transfer to the single mapper. That's correct. All right. Biswa, should we move on? Do you have a more question? Good question, yeah, Yashwant. All right. I think you got it. All right. Let's discuss few more things related to MapReduce. All right. So, a quick recap of HDFS, a quick recap of MapReduce process. We have now the input split. Now this input split makes sense to you. It's not the data block. It is the input split. Out of which, for each record, we are calling map function, and this map function is generating key value pairs, putting it in multiple buckets, or in case it's a single, if it's a single reducer it will keep it in a single bucket, and these buckets are carried to reducer node. This reducer node could be any one of these or could be third one, where they'll be transferred from all other nodes till that point, and then the reduce process would happen. Okay. Okay, so we could do these basically. Here you can see input split was created out of the data block from the HDFS, and then out of input split every record has been passed through map function, and map function generated many key values, and these key values are kept in the bucket here after sorting. So every node sorts the data, and then after sorting the data, when it's carried to the central place, it is merged with the rest of it. Merging the sorted data is far more easier to produce the sorted output as compared to merging the unsorted data to produce the sorted output. Okay. Similarly, if you have the multiple reducers, there will be multiple buckets. Now, question arises here is what happens, on what basis are we putting these these data into the multiple buckets? Okay, I'll come back to this. This is the main point which we are going to discuss here. So, input split is broken down into records by map, by input format, and for each record map your map function Okay, this is a logic written by you, that each record is passed through your map function, and your map function produces many keys and values for each record, and these key values are sorted and kept in these buckets here. Okay, these buckets here. Now if you have two reducers, there will be two buckets. Some keys will go into first bucket, some keys will go into the second bucket, and these buckets will be carried over to individual reducer where they will merge. Okay, where these buckets will merge to form a single bucket. Now the most important thing to notice is one key will not go to two reducer, it will always go to a single reducer. Also, your reduce function will get all the values for a key. Your reduce function will get all the values for a key. Okay, now on what basis this division happens? On what basis does do we send some of the records to one reducer, or some of the keys to one reducer, and some of the keys to another? On what basis? Okay, it is based on a piece called partitioner. Partitioner decides whether a key goes to zeroth reducer or key goes to first reducer. We'll call zeroth and first because that's how Hadoop identifies them. Okay, zeroth reducer means the first one, and the first reducer means the okay. So we'll just call them zeroth and first. Okay, so this decision of converting of this decision whether to take a particular key to a zeroth reducer or first reducer is taken by partitioner. You can see clearly the partitioner logic would be running here, would be running on every map, every mapper, just after sorting, just after the after mapper has given out the key. All right. So sometimes you may want to customize this logic. By default, this partitioner works on something called hash code. Okay, so based on hash code, hash code is a number generated out of a key, and based on hash code, it's put into a corresponding the bucket. Okay, let's say hash code is 15. Okay, and the way it happens is hash code percentage number of reducers. What does it mean? Let's say hash code is 11 and there are two reducers, meaning the remainder will be 1. So it will go to the first reducer. Okay, if hash code is 10 and there are two reducers, then it'll go to zeroth reducer. Okay, and if it is, so basically hash code is, let's say, this much, and we say 2, that means it will go to first reducer. Okay, this is the default logic. Hash code is computed of string, converting a string into a number. Okay, you can think of hash code as if you have summed up you have given the numbers of each character and you have summed up all those numbers, and then we start saying that to be a hash code. Okay, so had it been, let's say there were number of reducers are 3. Okay, number of reducers are 3, so 11 percentage 3 would lead to 2. Okay, and 10 percentage 3 would lead to what? um, it would lead to 1, and 9 percentage 3 would lead to 0th. So based on this, the key whose hash code is 11 will go to the second reducer. The key whose hash code is 10 would go to the first reducer, and the key whose hash code is 9 will go to the 0th reducer. All right, we will stick to this connotation as 0 1 2, as if it's like in lift we have ground 1 2 similarly. Okay, so we will keep that notation because otherwise we'll get confused. All right, now by default this is the logic, as in first compute the hash code of the key, then do the percentage of number of reducers, and then based on the outcome send the put this key in that particular bucket, and then carry that bucket over to the reducer. All right, now if you have to customize it, you can go to the you can basically extend partitioner. You can extend partitioner, and while extending partitioner, you will have to supply the input data types, as in the data type of the input key and the data type of input value. And based on that, you will have to return an integer. Your function is supposed to return an integer. Okay? Integers should start with 0. So here, what exactly are we trying to do? We are trying to say gender.getString equals m, then return 0, which means send mails to the 0th reducer and send rest of the people into the first reducer. We are trying to balance the reducers by this way. All right, all right. So we will take the questions after the break. All right, we will take the question, and let's have the break already. We are running 2 minutes past. Break for 10 minutes. Back by 8:43. All right, so I'm back. Should we start now? All right. Is everybody back? Should we start now? Hi Murli, hello Abhay, Atul, Bishwa, Mahesh ji, Mamta, Midli, Prezi. Should we start now? All right. All right. Keep asking questions as much as possible. It's okay if we get little bit delayed. That's completely okay. There's no. I mean, we can cover it up. That's not a problem. All right. Most important is to get your questions answered. All right. Midley's question is, can you explain the difference between shuffling and partitioning? Okay, so partitioning is a part of shuffling. Shuffling is composed of two parts. One is sorting and other is partitioning. All right. So we call that shuffling phase. Okay, because if you look at this diagram, what's happening here is the data is being shuffled. Okay, some part goes here, some part goes here, some part goes here, some part goes here, and so on. So this is shuffling. Partitioning is a part of shuffling. All right. There's a question from Biswa. Please let me know if my understanding is correct. For the following instance, I have a book for word count. Okay, and I decided to have each chapter as input split. Then each line is identified by control. What was okay? CRLF is considered as a record. Upon feeding this input split, that is, the content of the whole chapter, to the mapper, each record is processed and converted to the words. The mapper puts each word as a key and the null as the value to bucket. The content of the buckets are provided to the reduce for aggregation. Correct. That's correct. All right. Your understanding is correct. All right. Yes. Each record is given to your mapper function. All right. Yashwant's question is how to have um, chapter each chapter to be input split. You will have to use corresponding input format. If there is no such thing called no such input format which can convert the input data into the chapter wise input split, then you will have to create your own. All right. I'm assuming that the input format is capable of segregating chapters into input split. All right. Good. Everybody okay with this? Now, all right, let's have a look at what is the. All right, I'll show you some more things. Now, in the word count, which we earlier discussed, there was an interesting thing which we did not notice. Now, the output, even though we have multiple reducers, okay, what page is that? Yeah, I think. Okay, let's say uh, in the earlier, let's say we have apricot in the input, apple and banana and boy. Okay, so we have these this data, I mean this input keys, okay, the chances are that apricot and banana might go to first reducer, and second reducer will might get the other two. Now, as a result of word count, we will get two output files. As a result of word count, we will get two output file, one from first reducer and one from zeroth reducer. We'll call it zeroth reducer for keeping consistency, and other for the first reducer. Correct? Even though the result of reducer is sorted, as in apricot and banana, okay? But if you try to concatenate the result from reducer 0 and reducer 1, it's going to be it's going to look like this, which is not sorted. If you see, which is not sorted. This is not sorted, right? Now, what if you wanted to make sure that all the things starting with A go to the first reducer, while while the all the things starting with B should go to the second reducer. If you wanted to enforce this, why? Because that way, if you concatenate reducer 0 and reducer 1, you will get the right results. Correct? Now, in that case, the you will have to use the partitioner very cleverly. And you can see here we have created a partitioner example. This is an example for input format. You can take a look at this, and there will be, all right, in the other project which we have mentioned, in the other project there will be an example for chaining, character count, and custom record reader, where we'll have this. All right, here you can see there is a partitioner in that other project, in the second project. And what does this partitioner do? This partitioner sends the keys starting with A to K to the zeroth reducer. A to K, you can see all the keys that are starting before K go to the zeroth reducer, while other keys are going to the first reducer. So this partitioner does a great job of splitting the data such that everything before K goes to the first output file, and everything else after K goes to the second file. Now, once you have these two files, since the range of both is exclusive, we can simply concatenate the two, and the overall result will be sorted data. Okay, so these are the various reasons why would you like to use the partitioner. All right, and you can see clearly that it has to return the number. You got key and the value as the input, and number of reducers as configured in for this process. You got that also in the argument. All right. So that was the role of partitioner. Okay. Another, we already discussed this part called how to choose the number of reducers. Okay. By default, number of reducers are one. If you create too many reducers, the shuffling will be too high. If you create too few reducers, the computation would take a lot of time. You will have to tune it to have the to tune it to correspond to total number of slot. Okay, tune it to the number of slots. Okay, so number of slot means how many things can be executed on the cluster at any point. So you find out from each node how many tasks can be executed on every node, and based on that you sum it up and then say these are the total number of tasks that can be executed on each node. And somewhere between 0.75 to 1.95 times that value is the number of reducers. Okay. Uh, Biswa is saying that can you show this in diagram? You mean which one? The number of reducers? All right. So there are two questions. One is, all right. So the partitioner is here. Okay. The partitioner is here. This is the diagram which describes the partitioner. In this is where the partitioning is happening. All right, Vishwa? This diagram shows the partitioning happening here. This is where your partitioner is being executed and the data is going into two different buckets. All right. Now there is a question from Medley. If we have multiple reducers, we are getting multiple outputs right now. How can it be final result? So multiple files can be a final result, right? You don't necessarily need all of the data to be in a single file. All right. Let's say tomorrow you want to process this data, you want to put it somewhere, you can take both the files together. All right. Or if you want to concatenate these two files, you can concatenate at any point of time. So multiple files can be the output of a process. All right. All right. All right. All right. Let me see if everybody so everybody understood how what exactly this partitioner is doing. All right. All right. All right. So okay, let me just get all the contents from Bishwa. So his point is that he demonstrated in Java code the partitioner moves everything before k to one partitioner. That's correct. One bucket and rest to another. This will happen with each and every mapper resulting in the same issue. That's correct. So you can think of it this way that as soon as here at this point, so so you can diagrammatically this is how it would look like. This is how you will look like. Let's say there is this is our map. Okay. All right. Let me just choose some more decent color. All right. So when we get say A, okay, This A will go through our partitioner, and this is the zeroth reducer, okay, and this is our first reducer, okay. Now, all right, so if you have as an input, if you have, let's say you have apple, apricot, or it may not be in that order, okay, so apple, apricot, and say banana and boy, and say what do you call mango, okay, and melon. All right, so here if you see the way we have defined our partitioner, we have said that all the values which are lesser than k go to the zeroth reducer. So all of these will will go here, will reach here, correct, to the zeroth reducer, and the mango and the melon go here, okay, because they are greater than k. All right, for each of these will be passed to mapper, will be passed to the mapper, and they'll be going to these. Make sense to you now, Biswa? All right, good. All right, so I want to move to combiner now. All right, if you have any questions, we can discuss it again after some time. So question is, so the partitioner sits after the buckets are created and before move to the reducer? No. Partitioner is the one that creates the buckets. Okay? Partitioner decides which goes to what bucket. So partitioner essentially does the bucketing. Alright? So here, this is where at this point, you see the point here? Here, this is where just after the mapper will your partitioner be executed. Okay? Alright? Good. Good. Alright. So we have combiner functions. Now sometimes it is far more easier. Alright, let's recollect our problem of character counting. Let's recollect our problem of character counting. Okay, in the problem of character counting, let's say there is a file of 1 MB. Okay, it will have 1 million characters, right? 1 million characters. All right, and when we did the character counting program for each line, our mapper our mapper gave out gave out for each character for each character the char the actual character followed by 1, key as character and value as 1, right? So if you remember the first problem, whereby what we were trying to do is do the character count. So what we did was, just like the word count, we started with in the same fashion, right? Now if you look at this, for 1 MB file there are going to be 1 million characters, right? There are going to be 1 million keys, 1 million keys, and those keys will be transferred over the network here. So from here to here, all of this shuffling will take us a transfer of 1 million characters. Do we need that much? Can't we finish counting on the node itself and then transfer the count to the reducer? Can't we do something intermediate on the same node so that all the characters which are occurring on that particular node should be counted together? And after you count, how many values will there be? How many distinct characters are there? How many distinct characters are there? 26, right? So if you do the summarization on every node, then only 26 values will be carried in our case of character counting. We'll say A has occurred this time, B has occurred these many times, and so on. Therefore, you don't need to transfer 1 million keys for 1 MB file. And that's where the combiner comes into play. Combiner runs combiner runs on the same node after mapper has finished. After mapper has finished processing all the values, or while the mapper is processing, just after mapper before, while the sorting is happening, the combiner is executed. Okay, so combiner is executed in conjunction with sorting. Okay, while sorting is happening, combiner is also being executed. Combiner combines multiple values together on the same node. It's like a local reducer on the same node. It combines multiple values for a key on that node. Okay, so it helps us minimize the headache of reducer, minimize the data transfer, and but it does not replace the reducer. Why? Because same key might be existing on some other node which is not available on this node. Therefore therefore a combiner does not replace reducer, because reducer, at the end of day, we have to combine all the keys together. Okay, in the grouping, when we say group by clause, we need to combine all the values for a key together, right? Not only the values which are existing on one particular node. Therefore combiner does not obsolete the reducer's role. All right, that's what it does. So you can see that the input key values are fed to the mapper. Mapper generated intermediate key value pairs, and then the combiner combines them. After combining it, then the partitioner is called. Okay. All right. One question from Biswa is, what is the best practice for deciding when to use a combiner? Okay. So whenever, if you can use a combiner, use a combiner. All right. In a process, if your process allows, if your logic, if you are able to build a combiner part, then build the combiner part. All right. It's as simple as that. Now, next is, there is one question which I skipped. Um, There was one question I skipped. Yeah, there was question from Mahesh. Question was, is partitioner run for every mapper, that is one to one, or for every map function, for every key? I would say for every key. For every key, partitioner is executed. Okay, so every map function can give multiple keys. Therefore, 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 there cannot be, there can't be a single one-on-one, one-to-one mapping. Okay. A question from Yashwant is, if we have some idea about number of distinct keys and the count. Okay. Let me try to copy his full discussion. All right. Good. Now, question from Yashwant is, if we have some idea about number of distinct keys and the count is somewhat less, then we need to use the combiner. So my point is that you use the combiner if you can. Okay, use the combiner if you can, everywhere. All right, that's a simple word. If you feel that number of keys can be reduced without losing information, then better to use combiner. Yes. All right, let's say in our word count problem we can actually use combiner everywhere. It does not increase too much of overhead. It actually reduces the overhead in a very drastic sense. Try the advanced example, the one which we have given just now. In here, there is a care count problem. I have put a step driver called care count. Okay? Try running it. Try running it with and without the combiner. Okay, with and without the combiner. This is the line which you can comment. So partitioner, to run execute the partitioner, you can set the partitioner class. Similarly, to execute the combiner, you can set the combiner class. All right. So basically you should compare the results, the time taken for each part. It displays every map reduce process displays how much time it has taken to do various kinds of things. And let me see what happened to our, yeah, it has finished. So you can see our map reduce process, when it finishes, it shows you the detail about the total time spent and number of bytes that got transferred. Okay, so you must you must try this care count problem with and without the combiner class. You will know the difference. All right, now there are some catches. There are some catches. The catches are, not every reducer. So one more thing, the signature of a combiner is exactly same as reducer. In fact, you have to just extend reducer class for the combiner as well, right? Therefore, with respect to signature, there is not much of a difference for a combiner. The only big catch is that we can apply only those reducer function as combiner which which are what do you call, which have this property that no matter how many times we apply those functions, the result is going to be same. Okay, let's take the case of min, max and sum. No matter how we apply or no matter how many times we apply such function, the result is going to be same. For example, the max of 0, 20, 10, and 25 always is 20. Whether we compute the max of first two values and then compare the result with the second and then with the third, or we find out the max of last three and then compare that with the first two and then do the. So no matter where you put the brackets, no matter how many values you churn at a time, in what order, if the result is same, then that problem can be is suitable for combiner. Okay, the problem is suitable for combiner. Please pay attention to it. So for example, you look at the map max function. Max function has been applied on 0, 20, 10, 25. All right. Now, either we apply max function on all of the values together, we will always get 20, or we applied max function on 0 and 20 first, and then parallelly on 10 and 20, and then the resulting one we again applied max on those. So max of 0, 20 is 20, max of 10, 25 is 25, and the resulting is always 25, not 20, I'm sorry. So always, no matter in what manner we apply max function, the result is going to be 25. Now only such functions which have this kind of quality can only are only used with combiner. We can only use combiner in such kind of scenario. So max is a good combiner, similar is min, and similar is sum. Whether we sum up 0, 20 first, or okay, so no matter what manner we do the summation, we'll always get the same result. All right, no matter how we sum up the things. Let's say we have what are the things we have? Let's say we have 0, 20, 10, 25. Okay, 0, 20, 10, 25, right? So if we do the summation of these two first, so what we get? We get we get 45, 55, right? And then we sum up this with 0. That means the resultant is going to be 50 plus 0, which is 55, right? 55 plus 0 is 55. Again, you can see clearly that no matter how you apply these functions, the result of summation is going to be the same, no matter in what manner you are applying the summation. Okay, let's say we take middle two values first and then sum up the rest one. Let's say we sum up these two first. Okay, and so we sum up these two and then we sum up these two. Okay, and then parallelly we sum up both of them together. Okay, so we have 25 and 30, and then we sum up these two together. Okay, so we can basically we sum up this, it's always going to be 55. Okay, it's going to be 55 always. Okay, all right. There's a name for such functions. They are called, I think, um, they're called reflexive and something. I forgot the name. All right. Commutative. Yes. Thank you, Biswa. These are called commutative. Commutative and one more word we call it. I've just forgotten the name. All right. So the most important part is recognizing whether a particular function is commutative or not. Is it suitable for us? For example, let's take the case of average. Okay, average of 0, 20, 14, and 35. Okay, let's take the case of average. Average of an average is not equal to average of all the numbers. For example, if you take average of 20 and 0, it is, okay, let's try to compute using this diagram. So we say 0, 20, 14, and 35. Okay, help me out with this, all of you. Okay, yes, that's the term. It's called associative and cumulative. Cumulative, not cumulative, associative and cumulative. All right. So more important than this is understanding and figuring out whether a particular function is associative or cumulative. Let's run through very simple maths exercise, and try to see if average is average is associative and cumulative. Okay, so average of 0, 20, 35, and 14 is how much? Biswa is saying, yeah, how much is the average of these four values? Anyone? Overall, I'm asking for overall. All right, let's just try calculator. Okay, 20 plus 14 plus 35 divide by 4. So overall, the average, if you take all of them together, the is average of all of these is 17.5. All right. Okay, now the average of 0 and 20 is 10. That's correct, thank you. 19, 10, right? Now 14 and 35, the average is 24.5, and the average of 10 and 24.5 is average of 10 and 24.5 is 17.35. All right. So you can see that although the average of the whole thing is 17.25, the answer is here 17.35. And this answer will keep on varying a lot. Okay, if you try to compute the average of these three and then sum it up with 35 and then try to compute average, again the result will be different. So the average is not a commutative function. Okay, that's why these are the errors. So you cannot compute average, you cannot use average as combiner, while you could do counting, as well as you can do summation as part of combiner, but you cannot use average as combiner. So if you have to do the computation of average, you will have to break down the average into summation and counting. So let combiner do the process of computing the summation and count. At later point of time in the reduce, you only divide summation by count, and that's how you can do the average efficiently. Okay, you can convert the average computation problem in MapReduce into summation and counting problem, and let combiner and reduce phase do that for you. And as reduce phase, you can divide the summation after computing the summation. You can divide that by count, and you can compute the average. So keep that in mind. If you found out that your function is commutative, then you are lucky. Otherwise, you will have to figure out a way to convert your problem into such that it becomes uh, it becomes cumulative. Okay. All right. Mahesh says that average of 10 and 24 is 17.25. All right. All right. So we have been maybe lucky for this, but if you try to do for other values, say you try to combine 0 and 14 and 20 and 35, then the result will be different. Okay. I generally use the Python prompt for this. Okay. So we can say like this. We are trying to compute the average of these. Okay. Now 0, 20, 14, 35. Now 0 plus 20. I'll just define an average function. All right, let's say 0, 20. Okay, and 0, 14 is 7, and average of 20 and 35. Now average of 7 and 27.5. Alright, so we may be lucky in this case. Alright. Alright. So 17.5 and let's say 20, and then average of 18.75 with 14. You can see that when you try to try different combination, the results will be different. Okay, so average is not a function which can be used as a combiner. So you will always have to divide or convert your such kind of problems into something which can be worked upon by multiple mappers together. There are many benefits of converting your problem to combiners. First is that your sorting process is drastically reduced because you have decreased the data. Second, second, the data transfer is also reduced. So combiner is a very key idea, and always keep in mind that it is very important to understand combiner because we are going to use this combiner as part of any distributed computing. Okay, combiner is the true divide and conquer, or divide and conquer way. So if you can divide and conquer your problem, then you'll be able to solve the big data problems. Otherwise, otherwise you won't be able to solve your big data problems if you are not able to divide and conquer them. All right. Now coming back to it, so question to all of you is, if you have a function, let's say your function is this. Your function is this. This function computes a square root of summation of all the arguments. So let's say you give it a, b, and c, so it will compute the square root of a square plus b square plus c square and so on. Now question to all of you is this function appropriate for combiner? Anybody? Is this function appropriate for combiner? It's an aggregate function like you have in when you do group by on SQL. It's an aggregate function which aggregates many values together by computing square root of summation of the squares of individual values. So can we, if we wrote a function, if we wrote, let's say, let me just try to write something in Java, let's say Python, say f a comma b, or let's say f my array. Okay, and what this function is, what this function does is, whatever value you provide, it returns math dot square root of squares of summations. Okay, all right. Biswa says no. Abhay says yes. Anybody else? So let me just write sum equals 0.0, and for value in my array, all I'm going to do is I'm going to sum up, I'm going to add this a to sum, and then we return the, okay, I'm summing up the square, and then, yeah. So question is this function, is this function good for combiner? All right, I'll help you out with this. This is a very important aspect. So we are computing the summation of a, b, and c, correct? Let's just limit ourselves to three variables. Okay, now what is the value of a and c? Let's call it a1. Then what is the value of a1 and b? Is it equal to, okay, is it equal to f of a, b, comma c? Yes, anyone? Try. I think this is a very good exercise. So a1 is going to be square root of, quickly, so Mamta, Maheshji, and I think one more person said yes. Abhay said yes. And Mithili is saying yes. Let's try it. It will be very difficult to generalize. So Mahesh is saying because multiplication and addition are associative and cumulative, it should be yes. Not really. We cannot do that. Okay. So let's try to do. So what is the if for a and c, what will be the value? Square root of a square plus c square. That's right. And for a and b, it's going to be square root of a1 into a1 plus b into b. Now, square root of a1 into a1 is a into a plus c into c plus b into b. Now you can see that a1 square a1 square is equal to a square plus c square. That's what I've written here. This is a1 square. Therefore, this function this function is this function is good for combiner. On the same way, you can try it out. All right, you can try it out, and this is the only way to figure out if a function is commutative and associative, by trying it out. Yes. All right, does it make sense to you? Biswa, Mahesh, and everybody. Medley, Mamta, good job. You were able to figure out that it's all right. Second step. Okay. So what we are trying to do is we are trying to compute the value of if we give a, b, and c three variables, right? So function. Let's try to compute in parts and then try to fit in whether it works or not. So what will be the value of a, f, a, and c? Let's assume that it is a1. Okay. Or you have a, b, and c. Okay. So if you combine a and b together using this function, the result will be square root of a square plus b square. That's right. And then if you combine this value with c, if we combine this value will be c with c with c, the result will be, and let's call it for some time, let's call it a1. Okay, so the result here is going to be a1 is square root of a1 square plus c square. That's right, and which is equal to square root of the square of square root is this plus c square. So we broke down the problem into parts and it did work. All right. So, Biswa, we are not computing square root of summations. We are computing square root of sum of squares. So, what is a square? Or you can say here, if a1 is this, then a1 square is equal to a square plus b square, isn't it? And that's what we did. Biswa, are you with me? All right, everyone, feel free to ask questions as much as you can. All right, because these are very important ideas. The map and reduce actually started with this. The the actual definition of map and reduce started with this. Okay, so map and reduce was introduced as part of functional programming, where map converts just translates one array into another, while reduce reduces the array to singular value. Okay, so and all the reduce functions in the functional programming language were of this property. Okay, we are able to convert the sorting mechanism to to divide and conquer. Only then we are able to solve these big data problems. Had we not been able to convert the sorting algorithm to be distributed, to be of this nature that individual part can be sorted in on multiple computers, and then we will combine them together. Unless we had divided our problem, we would never have conquered this. So this is probably the most important idea behind the distributed computing. Ability to divide the work amongst many computers and then combine it together to solve the big problem. And that's what this cumulative and associative functions are all about. All right, you will see it again when we discuss Spark in session number 10. All right, good. I hope you are having good time. All right, now moving on. In the problem number 4 in of class 2, we were talking about multiple MapReduce processes. We talked about multiple MapReduce processes as part of that, right? Now, how would you execute multiple MapReduce in the chain? Okay, first we had to join the two lists, list 1 and list 2, based on the key, based on the voter, and then we had to group it by the votee, right, to combine the total vote count. In those kind of scenarios, if you think about it, you will need multiple MapReduce. You must have written already. I'll check this week and we'll get back. And so what you will do, you will have to do is you will have to have two MapReduce process, combine them together. Now, we all know that every MapReduce is a single phase, single process per se. It reads the data from HDFS, writes the data to HDFS. Although it can read from anywhere, but by default, that's the general behavior. So if you have to have a process such that it reads the output of the first one, it will have to obviously read from the HDFS. Okay, the direct communication between MapReduce one phase and second phase is not possible. So anyway, these two processes have to deal with reading the output of first one into the second one. Unless second one deletes the output of the first one, it will be there in the HDFS. Okay, so one very simple case is we use the most simple method is we create two job definition as part of our driver. So we create a driver, and inside the driver we create two jobs, and we wait for the completion of the first job, and we start the second job. Okay, method number 2 is using the Unix. In Unix, if you say command 1 ampersand command 2, it means command 2 will only be executed. Command 2 will only be executed. This is second part of the command. So command 1 ampersand command 2. Okay? So command 2 will only be executed if command 1 has successfully completed. So in a similar manner, we could have multiple MapReduce process like this using the Unix command. Now second one is using UZI. The third approach to chaining the MapReduce process is UZI. Okay, whereby whereby we will discuss that how can we create a workflow and let UZI execute your workflow in parallel. That UZI helps us chain one MapReduce with Pig, Hive, or any other process in the ecosystem. We will discuss that later. Method 4 is using dependencies. Okay, using dependencies such as, let's say you have two jobs. You can create the Hadoop API has come up with something called dependencies. Okay, so you can create two jobs, job 1 and job 2, and you can define that job 2 dot dependency job 1. So if you execute job 2, it will first execute job 1 and wait till the job 1 finishes, and then it will execute job 2. So these are the four methods of MapReduce job chaining. You should take a look at this particular project. I've created a sample project for you for the job chaining. Okay, so here you can see All right. You can see that. All right. You can see that we're creating first job. Okay, just like the way we did up to here. We created a job. Then we created a wrapper called controlled job over our job one. Okay, then we created job 2, and then we create another control job over job 2. We wrapped job 2 into control job here by saying this, and then we said control job 2 dot add depending job. We added that job. Okay, then we created something called job controller. Okay, we created something called job controller, and then as part of that we added both the job 1 and job 2. So effectively job controller is a DAG containing all information about dependencies between jobs, and then we handed over job controller to the thread. Now this thread will resolve the dependencies, and we figure out based on these dependencies which one need to be executed first or which one need to be executed last. Okay, and here we are monitoring. It's not required though, just that we are monitoring this job again and again. We are iterating over it, sleeping for some time, and then again iterating, and that's how we are monitoring whether the all jobs have finished or not. Okay, so this is called job chaining. This is called job chaining. All right. So there is some I one another aspect of Hadoop called pipes. If your code is written in C, C++, okay, then you can use pipes. It's nothing but same MapReduce, just that it's a little bit faster than the streaming. Instead of instead of directly calling the Java code, instead of wrapping the code inside Java code using Hadoop streaming, you use pipes in order to make it a little bit faster. Okay, as per them, the Hadoop pipes is faster than the streaming and is a better way of executing if you are trying to do MapReduce inside C, C++. All right. Now this is something very interesting aspect of Hadoop. It's called speculative execution. All right. Now it will be unfair to give equal work to all the nodes. Okay, it'll be unfair to give equal work to all the nodes. Why? Because some nodes might be slow. Now this unfairness might impact us. This unfairness might impact us in the sense that our overall job may not finish because of the some very slow nodes. So what can we do about that? Can we in a way make our overall job fast if we do not know that some of the nodes might be slow? All right, let me reword it again. So let's say we are trying to execute something on 5 nodes. Now out of these 5 nodes, some of these nodes will be really fast and some of these will be very slow, and you don't know right now which one are those. Okay, so you executed and first 4 nodes finished and the last one is still hanging. So as a matter of proactiveness, what Hadoop can do is Hadoop can execute the same work which is given to the fifth one to somebody else, somebody who has finished fastest amongst all, all of the 4. Out of the 4 who finish fastest, it will execute the remaining work which is given to fifth. It will execute on somebody else, which means the work which was given to fifth, is also being done by somebody else. There's a duplication of work, right? Intentionally, we are trying to do the duplication of work, saying, hey, I don't know about this guy. I'm not sure if he's going to finish it ever. Can you also start working on this? In case out of you or him, whosoever finishes first, we will consider their result. All right? It's the same way. Okay? So you can see that task 1, task 2, task 3, and task 4. 4 tasks were given to the task trackers. First 3 task trackers finished the work. Now the same task, task 4, will be given to task 3 from the beginning, from the zeroth. It's not like we are consuming some of the output done by task 4. No, we are just taking task 4 from the beginning and executing on this task tracker 3. And maybe the chances are the task tracker 3 may finish this work faster than the task 4, because task tracker 3 may be a better processor, may not be busy too much, or something else. Just as a speculative, just as hypothesizing that maybe this node which has already finished work faster, maybe this guy will finish first than the fourth one. So this is called the speculative execution. Now, because of the speculative execution, it helps to break down our work to many mappers into small part, so that we are able to quickly figure out in the beginning itself which nodes are slower, so that we don't give the work to those slower nodes and instead prefer the faster nodes. Biswa is saying, but this involves data movement also. Not always. There are high chances that this block, which is being processed by task tracker 4, exists on 3 more nodes, right? Because every block generally has a replication factor of 3. Maybe, maybe those the replica of this block is existing on 1, 2, or 3. Okay, so that's called speculative execution. All right, does it make sense to you? All right. The other important concept is data locality optimization. Although we have been talking from the beginning that the mapper executes the logic near the data, executes the code near the data. But this definition of nearness is something we need to clarify as part of data locality optimization. This is called this executing code near the data is called data locality optimization. All right, imagine there's a data center, and data center has 3 racks. What does it mean by a rack? Rack in itself is like a big almirah, and inside the rack, all the computers which are stacked are are a network, are connected to the same hub, which means the communication between the computers on the same hub is really fast as compared to the communication between the racks. Now all these racks in a data center are also connected together, and we call that data center. In the topology world, you can think of a data center as a connected component of the racks, and rack is a connected component of the computers. All right. So, and multiple data centers could be connected together. Now, if you look at here, the green colored one is map task, and I'm not sure it's green or red, and I'm a little colorblind. So an STFS block is the blue one. So the best case scenario is when when the data and the map task exist on the same node. A little worse is when nodes are different but on the same rack. The data and the logic is on the same rack. Here, the data is going to get transferred. The data is getting transferred to the node containing the logic on the same rack but different computer. But the worst case scenario is when the data is on one rack and the logic is on another. Data is on one rack and map task is on another. Data SDFS block is going to be transferred to the map task and it's going to take time. So the best case scenario is the first one. Now, how do Hadoop figure this out, that what is a rack and what is a data center? We will have to configure it. We'll have to convert our individual nodes into a tree hierarchy. We'll have to define that to Hadoop. We will have to tell that to Hadoop. And that's a very nice and very important aspect of this. Okay. All right. So this was data locality optimization. We'll show you some more things. So can reducer takes the benefit of data locality optimization? Anyone? Okay. Yes, one's question was, I missed the question. Should it be move having the same data copy? Yes, that will be preferable. Correct. It can't. So reducer can generally not take the benefit of data locality, because anyway the data will be transferred to the reducer. The chances are the data has to be transferred to other reducer, other node which is running the reducer. All right. Another important thing which we need to know is, if you have to store a file with the replication factor of 3, on which all nodes will Hadoop store the replica of a particular block? So this is called data placement policy. Okay, data placement policy. Correct, correct. So yes. So generally, the first one will be on the same machine on which we are doing Hadoop CP or Hadoop copy from local. It'll be on the same machine. When we say Hadoop copy from local, it's most likely just taking your data, moving on the same computer into a block. Okay? Because this computer, if this is running Hadoop as well, if this node is inside the Hadoop, then it will just take a file, move that to somewhere, to the blocks, right? The second one, first one will be on the local node, second one will be on the same rack as local node, and third one will be off the rack. Okay, so have a look at the data placement policy here. This is a data placement. I have written a little bit description about data placement policy. Okay, so data placement policy is an important part of HDFS. Okay, all right. So how do we define network topology? We convert the network topology into the tree. And what does it mean by converting it to tree? How does it help? It helps in the sense that it becomes very easy to find the distance between two nodes. And how do you compute the distance between two nodes? By finding the common ancestor and then summing up the distance from common ancestor. For example, the common ancestor of node 1 and node 3 is, anybody? Node 1 and node 3, what's the common ancestor? Correct, it's rack 1. So the distance between node 1 and rack 1 is 1, and node 3 and rack 1 is 1. Therefore, the distance between node 1 and node 3 is 2, right? Similarly, the distance between node 1 and node 4 is how much? Anybody? Node 1 and node 4? node 1 and node 4? All right. Okay, let me take a step back and ask you another thing. So who is the common ancestor of node 1 and node 4? Who is the common ancestor of node 1 and node 4? The common parent. Correct. It's switch 1. Now, distance between node 1 and switch 1 is good. All right, that's correct. So basically, the distance between node 1 and switch 1 is 2, and switch 1 and node 4 is 2. Therefore, the total distance is 2 plus 2. 1, 2, 3, 4. Okay? And given two, and this tree can be represented like a file path, like this: slash s1 r1 n1 slash s1 r1 n2 and so on. Okay, so this is how we do the network topology. So it is also called rack awareness, that Hadoop knows about racks, and Hadoop understands the meaning of racks and data locality. It understands the network as a tree. It's similar to a file path like slash a slash b slash c, and this particular property in the configuration provides, if you look at the configuration file, there will be something called topology.script.file name. This particular key has a value which points to a script, and this script translate domain name system to switch mapping. This particular script converts a given IP address into a file path. Okay, now by default the algorithm in Hadoop is, it will take the IP address, replace the dot with a slash, and that will become the file path, like for example this one, and will compute the distance between these two file paths by finding the common ancestor. So here and here the common ancestor is 1, and therefore the distance between it is 2. All right. So the distance, as the distance grows down, the bandwidth, as the distance grows, the bandwidth also is is smaller. Farther are the two nodes, the bandwidth is smaller. Okay. So anybody can help me with this? So the distance between slash d1 slash r1 slash n1 and slash d1 slash r1 and slash n1. So distance between node 1 and node 1 is, anybody? Correct. That's 0. And distance between n1 and n2, the second one. So their common ancestor is r1. Distance between r1 and n1 is 1. r1 and n2 is 1. So the overall distance is, that's right. The distance second one is 2. The distance between r the third one, the common parent is d1. Note that the common parent is d1. Correct. It is 4. And the distance between this and this, these are in two different data centers. That's right. The distance is 6. All right. So that's how it's computed. All right. That concludes our discussion on Hadoop MapReduce. If you have any questions, feel free to reach out to me. Also, try solving the second problem which we have given you as assignment, so that we can discuss it again in the in the next session. All right. All right. Is everybody with me in this? So feel free to reach out to me if you have any questions on Hadoop or HDFS, and then we will anyway proceed with the pig in the next week. All right. All right. Have a great day. Please feel free to respond to the survey which you will get. All right. All right. Thank you, Murli. Thank you, Mahesh. Thank you, Midli. Thank you, Atul. Thank you, Abhay. Thank you, Mahesh. Thank you, Mamta. Thank you, Prezi. Thank you, Yashwant. All right. Great. See you on the next Saturday and have a great day. For those who are in US, it'll be Friday for them. All right. Bye bye.